All right, so now that we have learned the features of sinusoidal graphs, now we're going to break them apart and graph sine, cosine, tan, cotan, cosecant, and secant. So there's going to be a series of videos to watch. Now, we're going to start with graphing sine, and the easiest way that I find to graph sine is to go through your quadrantal angles. In other words, we're going to go through 0 degrees, which is right here, 90 degrees, which is right here, 180, 270, and back up to 360. And we'll just cycle through those over and over again and not worry so much about the things in between, although you can, and sometimes with tan we do. So when we're going through this, what I want to look at is if you have the sine of 0 degrees. So if we're doing the sine of 0 degrees, right, it would be opposite over adjacent, or the y value over the r value. So the reason we pick quadrantal angles is that we always make the radius length 1, and then we make it so that either the x or the y value is 1. So if I ask you the sine of 0, it would be the y value, which is 0, over the r value, which is 1, which would be 0. Which means that when x is 0 degrees, actually I should be talking in radians, sorry. I got stuck in degrees there. When we're in sine of 0 radians, the y value, or your output, would also be 0. And then we'll move to pi by 2. So this is pi by 2 up here. And the point here is 0, 1. So again, if we were going to do the sine of pi by 2, it'd be the y value, which is 1, over the r value, which is 1, which means the output is 1. So at pi by 2, the y value is 1. Then we go over here to pi, and we have a point here at -1, 0. So this time we're doing the sine of pi, and it's the y value, which is 0, over the r value, which is 1, which equals 0. So we're going up to 1 and then back down to 0 at pi. Then we're going to move down to 3 pi by 2. Sorry, I almost said 270 there. So we've got 0, -1. And this time we're going to do the sine of 3 pi by 2, which is the y value, which is -1, over the r value, which is 1, which gives you a value of -1. So at 3 pi by 2, we're down to -1. And then what happens when we get up to 2 pi? Well, we're just cycling through again. 2 pi is coterminal to 0 pi. So we're back up to 0. And this is one complete cycle of sine. Now, if we wanted to keep going, we would just go back up to here. So we'd have 2 pi plus another pi by 2, which is 5 pi by 2, and we go back up to 1. And then we go to 2 pi plus pi, right, which is going to take us, did I just say that right? Oh, there we go. Then we're at 2 pi plus pi, which is going to take us to 3 pi, where we're back at 0. And then we're going to go to -1, and then we're going to go back up to 0. So the cycle continues because we keep going round and round the circle. Now, what if I went in a clockwise direction? So what if I started at 0 pi and I went down to -pi by 2? Well, then I'm down to -1. And then at -pi, I'm back to 0. And then at -3 pi by 2, I'm up to +1. And at -2 pi, I'm back down to 0. And so the cycle continues, and you get this sinusoidal, shape. And they don't end at 4 pi, they don't end at -2 pi, so the curve should keep going as well as you're going. Now, this is how I graph a sine curve, a cosine curve, a tan curve, and so on and so forth. I go to these quadrantal angles, and then I figure out what would be the value of y when x is 0, pi by 2, pi, 3 pi by 2, and 2 pi, and then I can graph these cycles of sine. Now, a couple other things that I want to focus on while I'm doing this, because it'll help us with some other graphs, is that when you're between 0 and pi by 2, you're in the first quadrant. And in the first quadrant, I'm just going to draw it like here. So we've got first quadrant, second quadrant, third quadrant, and fourth quadrant. And in the first quadrant, all are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, cosine is positive. So as we go through this, quadrant 1, sine is positive. Quadrant 2, sine is still positive. Quadrant 3, sine is negative. And in quadrant 4, sine is negative. And so you can kind of figure out where you're going to be based on the sign of your trig function as well. So that's it. That's building the sine curve. So what I wanted to show you quickly is this little video, which is a replication of what we just did. So we took this, grid, this 4-quadrant system, and we made it into this linear graph, right? So we went from a circular function into this linear function, well, into an XY plane. And I just want to show you this really cool animation that I found of them kind of going through it. So we're starting at 0 radians. Now, one thing I want you to notice about the x-axis is that they didn't put it in terms of pi. They put pi as decimals. So when you're at 2 here, what would that be? Like 2 divided by 3 pi, you're like almost all the way to, well, you're not, you're like 2/3 of the way to pi. So it is a little bit weird, so pi would be somewhere in here, like 3.14, this would be 1 pi. So to get us a full cycle, we're gonna go to what, 6.28. So one complete cycle of a circle will end about here. So I'm gonna hit play, and I'm gonna pause it a few times. So we're gonna hit play, we go through, and I'm going to hit pause. Whoop, back a little bit. So this is, a little bit more. This is pi by 2, okay, approximately. It's not perfect. But what we've just done is we've gone through, I don't know if you can see it here, but what we've gone through here is from 0 to pi by 2. So we went up in values up to +1, and then we're going to have it go down. So now we're going to play again. And we're going through the circle till we get back, pretty close, till we get back to 0. And so as we're going through these values of theta, we get these outputs, and we went from 0 up to 1, back down to 0, and now we're going to go down to 3 pi by 2, down to -1, and then back up to 2 pi, which is back to 0. And that's one complete cycle of sine. And the last thing we have to do is just go through the features. So what is the amplitude of a sine curve? Well, it goes up to 1 and down to -1, so the amplitude is 1. The center line is this line that you oscillate about, and the center line is only important when we start transforming these graphs. So if you think about your center line being the place that you're going up and down from, you can move this center line up and down, and it can help you kind of frame your graph. The period of a sine curve we know is 2 pi. The x-intercept, well, there's an x-intercept at 0, there's an x-intercept at pi, there's an x-intercept at 2 pi, 3 pi, 4 pi, -2 pi. So we say that the x-intercepts are every n pi, where n is an element or a member of the integer system. So we could put in n is 0, and we get an x-intercept at 0. We could put in n is 1, we get an x-intercept at pi. We could put in 2, 3, 4, -1, and so on. The domain of a sine curve is -infinity to infinity, or XER, depending upon if you like set notation or interval notation, doesn't matter to me. And the range is from -1 to 1, or in set notation, -1. So y is, whoa, that came out funky. Y is greater than or equal to -1 and less than or equal to 1. So again, I don't care whether you're doing set notation or you do interval notation, whatever makes the most sense to you. And that's graphing a sine curve as easy as we can.